Working out. Whatever.
It's just calibrating right now. Okay, you're gonna go.
Go now, right?
Cut the wheel, hit the gas.
Is it what?
That's forward. That's brake. The reverse is gonna hit you forward. Yep. Yeah, boy. Yeah, boy. Hold it. Yes. Cool, just good stuff. Go. You're ready.
Break it. It's real Sega. What is it?
We don't have wire.
What is it?
From the Sega.
Oh, super fan. I like this. This is cool. I'm scared. That's it?
Yeah, well,
I mean, no, not that's it. I mean, like, that's how it ends.
Yeah.
It lets you.
It'll power down.
But then I start again and then just do it again.
It'll power back up, yeah.
Wow.
So, this is pneumatic?
Cool. It's really cool.
No,
I
they're
really like this.
DC actuators.
Ah.
They're 12 volts, 20 amp actuators.
I just really want to
250 pounds. 2.9 inches per second under max, so 1.9 inches per second. This pretty power supply for that? This power supply for that?
This is the power supply and this is the motor controller. All of this is motor controller pretty much. But it also requires feedback from here.
So you're doing something wirelessly?
Right here.
When that thing gets going, it's kind of
It
like
is an RCR simulator.
Well,
It's dual implicit feedback control
about
system.
15 miles an hour.
So
That's something I can run,
there's
so
the
that's
car and there's the operator. That?
Does both.
Okay.
Yeah. You drive the car and the car drives you. Same time.
All right. When you get in, it's going to power on, so don't touch the steering or the pedal.
So what's the
And I'll let you
application?
know how it goes.
It can very easily be assimilated to any other simulator, really. We just wanted it to be challenging by doing both things, but it's mostly fun.
Like a Mars rover controlled by scientists on Earth?
What's that?
Like you have a Mars rover,
Yeah.
act as a Mars, like.
That would be
yeah.
sweet. That would be really fun.
So it's like operated by a human on Earth.
Exactly.
Yeah. So you have drag racing on Mars, but the operators are
I
here.
like this guy. He's the genius. It's a good idea. We should advertise that.
So like you did the programming.
Again, I'm going to say it's drag racing on Mars.
Yeah.
That's what this is for about.
So what microcontroller you use?
This is an Arduino, and that's a Netuino.
Ah.
Pretty much a 32-bit Arduino. 48 megahertz instead of 60 megahertz.
It gets pitched pretty good on it.
Eating?
It's getting a little warm. Doesn't I took the top off of it, so it
yeah.
doesn't have the same kind of circulation. So, yeah.
All right. Good work, guys.
Thanks very much.
What's the brakes? I mean, like, what's typical? What brakes I have? Between 30 and 40. Yeah, giant. That is our like. Pretty much. I got a pretty nice outrange.
Sorry.
That's okay. That's good.
Yeah.
It is
Too much fun to ride. Too much fun. Really easy to ride. And it's super small. Oh yeah, like a nice padded seat, nice padded headrest.
Is it available online?
No problem, guys.
No? Where are you making the online store for this? You pretty can start production of this.
If you got $5,000, we can make you one.
Okay.
I'll give you
Hey. Going? I saw the video. You just added the clip around the tree. You can add more.
He really wanted us to do that.
Actually falling on ground.
That's what the all.
That video was good. Actually, I like it. So you're riding this thing now?
That's just the microsoft project. The microsoft project.
The one that the guy was like.
Yeah. You just need to make it adjustable.
It is. You can move it up and down.
Ah. Riders are more prone to sleep. It's like you're too comfortable. You can sleep while riding it.
Now it's just a quarter mile. We haven't gone like. Were they gonna go to like Jay Blanchard and just like roping off an area? We could have been. Yeah. So just saying, hey, we're gonna do a speed test. And just go as fast as we can. Members that to get out, you have to go like the wheels to the side.
Yeah, well, how do you... I haven't seen the fairing around it.
Yes, you can. The bottom of the wheels out. So that's going to be the hat.
Yeah. Okay.
There's the body right there. This area. This area.
So can you roll over?
You can make shatters. Next picture's game is determination. They're using a vacuum pump from NASA. They have a month last they're giving us some altitude.
Yeah, so you tested the one speed breakers?
What was that?
You tested this bicycle for speed breaker, like bumping?
It's well, I mean, it's designed the competition basically. There's a drag race and a utility event, and I mean, the safety requirements involve you have to have a roll cage basically. So the competition, we wanted to make it as light as possible, as fast as possible. So I mean, that's why we have that carbon fiber roll cage. There's not a roll cage on there. So I mean, that kind of balances the safety and being able to get it to go as quickly as possible. We've only had it up to about 31 miles per hour or so. But that's in a quarter mile, so that's not too bad. We're hoping to get it closer to 40. This thing likes to follow. Simulation. It survived. Survived a few of those, unfortunately.
When you started this thing?
We started the design in September or so.
Okay.
End of September, and then we started construction in January, February. So. It's been a long road, but now we're doing just sort of the stuff where it's like kind of finishing up. So we basically have the frame done, except for we have to combine the two halves and mount it.
So you get all funding from NASA?
No, actually, we have our funding is from UCF, and then we had some sponsorship help from Cat Trike, they're the company that builds cover trikes and bikes, and from Vectorworks Marine, they're a boat building company actually, and they helped us out. And then we had initially had met with NASA and unfortunately they weren't able to help us out as much as they thought they were. One of the people who works in that lab is friends with one of the people on our team, so he was able to give us some vacuum bagging supplies and things like that.
So you're like you're trying to covering it all over?
Covered. There's a couple.
I can see you have covered from the two sides. Are you covering from the front too?
I'll show you actually a picture here. this is basically what it'll look like. There'll be a window cut out of there, obviously, but that's essentially what it'll look like once it's mounted on there. So it's
And after that, you can mount AC inside that.
what was that?
You can mount air conditioning inside that.
Yeah, we're actually not going to ride for the 2.5-hour endurance event with the fairing, just because of that, because it'll get so warm in there. The benefit of having your riders be comfortable for a longer period of time is a little bit more than the aerodynamics there. But we're hoping that in the drag event, when we ride with that, we'll only be a few seconds at a time, a minute at a time, so it should be able to work out pretty well. So, any other questions?
Good work, guys.
Well, our diameter is roughly that, but they measure them based off of Newton seconds, how much fuel they generate. I think as much as like 3,000 Newton seconds or so. Oh yeah, it's 19 inches long. The motor tube is like from here to here, and it's like that big around. Yeah, you know more about it than I do.
When I was a kid, we shoot like D or E engines. That would be like the top. I'm just wondering how big.
But dude, I mean, this thing's like 30 pounds, so it like.
So 4-key protocol, is that?
Sure, I just wondering.
4-key protocol, huh?
That's awesome. You guys have a parachute system?
Yeah, dual stage. Drogue and apogee and main deposit 700. It's really crappy. Yeah, we're not done yet. Next week will be a launch day, and then we're you're launching again.
So this is the internal design of that thing?
Yeah, so this is our payload bay. So our concept for our experiment is using these things called plasma actuators to actually correct the roll of the rocket. So as it goes up, they usually have their own natural tendency to roll, and you lose altitude because of that. So we want to mitigate that roll, and these actuators will kind of act like ailerons to control it, but instead of a mechanical system, it's purely electrical.
How are you doing the guiding calibration?
So we've got this Arduino. It's acting as our microcontroller, and we've got a gyro sensor that senses the roll.
Sensor, accelerometer, or latitude, altitude meter?
We have altimeters here as well, but the gyro, it senses the roll rate of the rocket, and based off of that roll rate, it'll turn on the corresponding pair for our actuators to mitigate that roll.
So, you made any flight?
We did fly it. We flown it once. Right here. Video.
How far it go?
It went 3,300 feet. We were shooting for miles, so we undershot a little bit, but there are a couple of factors. So you can see our engine's chuffing there, so we lost some altitude because of that. We lost thrust of our engine. Another reason was we have a very large static margin on our rocket. It was very heavy, or very windy that day, so it was real, one it's weather cost, wanted to point right into the direction of the wind, so we lost altitude for that reason as well. But we've got another launch coming up a week from tomorrow up in Huntsville, Alabama for our competition flight, so we're hoping to do better there.
Yeah. So it's like totally funded by NASA?
So far, like we got a grant from the Florida Space Grant Consortium for $2,000, and we got $1,000 from SGA.
So how much you have already spent in total?
It's been about like $3,000. For the most part, we've had to fund it out of pocket and just wait for the grant money to reimburse us. Right now, I'm waiting for $500 to come back.
Oh.
So I have like $500 each.
So this is the plasma actuator?
So that's a plasma actuator if you want to see the demonstration. So right now you've got fairly steady stream. The wind is kind of hurting me right now, but when I turn it on, you should hopefully see the airflow get disrupted. Yeah, this wind is killing me. It's hard to see because the wind is already just disrupted it. But if you want to actually see the plasma, if you come over to the side, look closely, you'll see that purple glow.
So it's kind of like diverting the wind.
Right, so basically what's happening is that plasma, there's all these charged particles, and those charged particles are cascading down that actuator and interacting with the air molecules.
So yeah, this plasma actually making a way for your rocket.
Right.
So if you covering your rocket with this material and when just go off.
Well, right now we only have them on our fins, so we're just using them like ailerons on an airplane. So we're just changing the airflow characteristics. So
I got it. This thing that you made like this without charging and this output starting
essentially,
thing.
I mean, you can put actuators across down the whole entire rocket and accelerate the airflow.
So you're basically reducing the resistance, friction between air and your rocket, and so that you reduce the fuel consumption out of that.
Right. That's what we're hoping to do.
When did you start it?
What's up?
When you started this thing?
We started it last fall, or in the fall.
September?
Yeah, like September time. So it's been a year-long project, a little less than a year.
That's good. Good luck. Good work.
Thanks for coming.
Good. So drone?
What's that?
I've seen this kind of like small thing. You can fly. So what basically like you're demonstrating your aerodynamics thing over here?
The goal is to actually fly it and lift the most weight possible.
Oh.
So this is our payload, and we put a bunch of pieces of that in there and try to lift it or fly it.
Yeah, there's actually a team that's right in there, and they have a smaller hand-thrown one. They're going to the same competition as we are, actually.
Oh, okay.
Class.
So this is made of
Wood.
wood? Okay.
We have a little bit of plastic up there and one aluminum piece back here, but the rest is wood.
Are you controlling this thing? Are you controlling?
Yeah. Remote control with servos and stuff.
Where's the power?
The engine is up there. We didn't bring the propeller because we only have one of those. We didn't want to damage it.
It's it's a gas. Okay.
When we performed static thrust tests, we were getting around 7.5 pounds of thrust. This right here.
Just goes down from the screw, places the hand, just square face out the place. This bearing is about the one thing I'm really happy about is on tool itself. So listen, and so the bearing is only 850. The cover itself, so right now we have these are actual the one thing that we're very proud
Anybody got things swimming around?
I saw a couple of the other people's presentations. It's just that just like jumping around in the presentation. That'd be fair. I'm sitting there, I'm like, I said, my watch might be in blood, you know, I'm like, practice room.
That's what I'm here for.
Like, you take a couple weight, it counts down, and then when you're out of class, something like that. Yeah, I mean, like I came in, I hung out at the shop like one day, basically. It was just like I didn't have to go to work. Are you trying to buy a race there? I don't remember. I talked to one guy that I guess has graduated, but he's still like active. Yeah, I mean, that guy. Talk to that guy. How you doing?
Good.
Yeah. So I was talking to him, and the I can't remember his name, but the really tall guy.
Two sensors are in place on either side, and wherever the main light is, they're both going to turn until it equalizes.
This isn't really my realm of stuff. I find really solar
And then it'll align it.
I've been trying to find articles that
Like this pocket is more reference to this pocket and together. You know, sometimes if there's cloud coverage, it needs to adjust for that. So that's why we went ahead with that. This here is our
and then I've been trying to, I've been looking into a lot of data acquisition papers and stuff, because I've been trying to figure out if senior research are required so that I can see how the car is reacting to changes that I've made. Honestly, like, have this RC car, and I like to put open stuff. Like, I like to
It's not bad. But when you put $2,000 in just machining, and then you have to buy $800 worth of reflective material and stuff, then the cost is just we're just glad to have all the pieces we missing. And just can't wait to get the last pieces to the machine shop.
yes, we will. We'll have all of our parts will be done by Monday afternoon. We'll have these guys will be done tonight, and then the actual inner frame plates, or what Dennis likes to call them, the little clown smiley faces, whatever he wants to call them. They'll be done Monday. And then it's really we've always been like tight because see a lot of the weight will be resting on this inner counterboard. The counterboard is going to hold the weight of it. So
So it really doesn't. You guys really have the whole because it's interfering with the wall and all that. You know, the back one you screw it in.
Tap it in from the down.
So we lost it.
And now you turn the crank and it lifts it up. Trolley here has that wheel. Once this is lifted where you want it, you then pin it to the trolley and locks it in. And then now when you pull the hand crank, it's moving horizontally along the track. You get it to a position where you want to drop it, and you just get a pin on it and lift it up.
I can handle the thing. Like I
Solar power boat.
Goody, goody! Look at this. So like, I guess like it's powered by solar cells, but it's grass instead.
This is a panel, a solar panel?
It's gotta be, yeah. What's this made of?
Is the solar panel you missing in the back?
No, there's supposed to be no solar panel. Hello. A solar panel under this? Is there a solar panel under this?
No, we were thinking of putting a solar panel on the whole thing, but we didn't have enough money.
Where is she? Like I saw cars like, oh there.
Yeah, we're pre-med, so you don't understand too much in chemistry and physics. And in my case, calculus 3.
We feel the same way going together.
Wait, so how does it work?
Except M&M major don't need calc 3, I was taking it for fun. And I'm going with a higher grade too.
Motor eléctrico.
Here it's
Una fracción del
a parallel hybrid drivetrain. It powers, it can run on both electric and gas, or it can run independently on just electric or just the gas.
Oh. Huh. Oh, so it's kind of like a Prius.
Yeah, it's exactly like Prius, same drivetrain and everything. And when you brake, it recharges the battery, so it's general braking.
You still got a Lego class?
And underneath the seat here, we have a battery charger, so you can plug it into the wall and charge the batteries.
Huh.
We also have instrumentation. It's not hooked up right now, but it displays all the state of charge of the batteries and fuel consumption.
So like, if one battery is like not charged, like will the other 3 work independently of the one?
Well, the batteries.
Like, is it like parallel circuitry, I guess?
Yeah, it's